Hello and welcome to the wave intensity calculations video. This is video Waves.3B. In this video we will do a few examples of how to solve for intensity level changes and sound level changes in the sound waves using the beta equation, so you are more familiar with that. All right, so let's take a look at this. The intensity of an earthquake wave detected 100 kilometers from the source is 1.0 times 10 to the 6th watts per square meter. What is the intensity of the wave if it is detected 400 kilometers from the source? Okay, so there's a couple of different things that we have going on here. We have an R1, we have an I1, we have an R2, and we are looking for I2. There's a couple of different ways to do this. The easiest way, however, is to remember that the intensity decreases with the square of the distance. So we can make a proportion that says that I2 to I1 is equal to R1 squared over R2 squared. And then if we go ahead and rearrange this and plug numbers in, that means that I2 is equal to I1 times R1 squared over R2 squared, or 1.0 times 10 to the 6th times 100 squared over 400 squared. Now notice that I've left the distances in kilometers, and the reason I can do that is because they're both in kilometers. So kilometers squared over kilometers squared cancel out, so we don't have to worry about it. If they were given in different units, then we would have to change them to make sure that they are in fact the same. Plug this into the calculator, solve it, and we find out that the second intensity is 6.3 times 10 to the 4th watts per square meter. So this ratio is a good ratio to use often in these equations when you know the intensities and the distances and you're trying to figure out one of the other intensities, or you know the intensities and you're trying to find out one of the distances. Let's look at another one. At a busy street corner, the sound level is 75 decibels. What is the intensity of sound there? Okay, so this is actually talking about the relationship between the sound level and the intensity. So we have to use the equation with beta. That beta is equal to 10 log of I over I naught. Keeping in mind that I naught is the threshold of hearing. So it's 1.0 times 10 to the negative 12 watts per square meter. If I were looking for the intensity, the I, so if I want to rearrange this for I end up with log of I over I naught equals beta over 10. Remember that x log y is the same thing as y equals 10 to the x. Okay, so I can take this log I over I naught equals beta over 10 and rearrange it using this equivalency and end up with I over I naught equaling 10 to the beta over 10. So now I know that my beta is 75. I know my I naught. I can go ahead and plug some numbers in here. And I is equal to 1.0 times 10 to the negative 12 times 10 to the 7.5, because 75 divided by 10 is 7.5. Plug that into the calculator and I find out that the intensity on a busy street corner at 75 decibels is 3.2 times 10 to the negative 5 watts per square meter. So again, not very difficult in terms of what the math is that we're talking about or in terms of the setup of the problem, but you've got to remember this relationship between logs and exponents and know how to use it. All right, let's do one more. The sound level measured 30 meters from a jet plane is 140 decibels. What is the sound level at 300 meters? So we're trying to figure out the sound level and not the intensity. There's actually two ways that you could approach this problem. One is through the intensities and the other one is through the sound levels. So let's do the problem based on intensities first, and then we'll look at how you would do it without going through the intensities. Based on the information that we're given, the beta equation would become 140 is equal to 10 log I over 10 to the negative 12. So 10 to the 14th is equal to 1 over 10 to the negative 12. So, sorry, not 1, I. So I is equal to 10 squared, or 100 watts per square meter. That gives me the intensity at the 30 meters away. I am looking for the intensity at 300 meters. So at 300 meters, we are 10 times as far. So the intensity will be 1 over 10 squared, or 1 over 100. So it'll be 1/100th as much, which will mean that it will be 1 watt per square meter. Because again, we're going 10 times as far away. We know that intensity decreases as 1 over r squared. So if we now know that the intensity at my 300 meter mark is 1, then we can plug in the beta equation again. And we can say that, all right, well then we are looking for beta now when intensity is 1. So it's 10 times the log of 1 over 10 to the negative 12. We solve that and beta is 120 decibels. Still above or at the threshold of pain, but considerably less than when you are 30 meters away. So this is a little bit of a roundabout, confusing way to do it because you have sound levels. You change them to intensities. You then figure out your intensity at your second spot. Then you change that back to a sound level. You don't have to do that. We can solve it a completely different way that you've probably already thought of, but I'll put it down anyways. As we said before, for the radius to go to 10 times the radius, the intensity is going to decrease by 1 over 10 squared, as we said, or 1/100th. We can use the result that 10 decibels correspond to an intensity change by a factor of 10. So then the intensity change by a factor of 100 corresponds to a sound change of 2 times 10, or 20 decibels. So one more time, 10 decibels corresponds to a change in intensity of a factor of 10. So a change in intensity by a factor of 100 corresponds to twice that. So you have a change in sound level of 20 decibels. And then if you start with 140, and you know you're going away from the source, so it's going to decrease by 20 decibels, the ending sound level is 120 decibels. So it doesn't matter which way you solve these problems, you can reason them out or you can do them using the beta equation. However, if you're going to reason them out, as I did here on the right-hand side, you're going to have to include words so that I understand what you're talking about. Because if I were to read a problem that looked like the right-hand side of this page, I would have no idea what you were talking about. So make sure that you include enough words with your reasoning out explanation so that I can give you full points for it. These three problems pretty much cover the types of problems that we're going to be looking at with sound intensity and sound levels. So you are now good to go on the assignment. Bye for now.